Today's lesson is on the topic of compressed air. This is our second lesson in our block on pneumatics and hydraulics. And so in our study of pneumatics so far, we looked at the idea of how our lungs represent to us a perfect example of a pneumatic system. Our lungs, with our diaphragm, are able to create a vacuum drawing air in and are able to compress that air and force it back out of our lungs. That, of course, is our process of breathing. So, if we know how our lungs work, then we can also begin to understand how mechanisms are devised to compress air and to use compressed air. So, how do they work? Well, our first thing that we should imagine is how does a balloon work? A balloon, of course, is something that is made out of rubber. It is a flexible, elastic thing so that it can expand, stretch out to a certain size, and then it can contract back to its original size. Our lungs are similar in many ways to that. They can expand, and they can contract, and they hold air at different pressure than the air outside of us. So, when we blow up a balloon, we are taking pressurized air out of our lungs, and we are forcing that air into a contained space. And the contained space we're forcing it into has that flexibility and elasticity that it can expand and still contain that air without releasing it. So, a balloon is a great way for us to begin understanding what is necessary to store air. We need some flexibility. Now, today's lesson, we're going to look at a few different areas in which we store air and how we produce the air that we're going to store. One of the first things that we could think about is a pneumatic tire. That's the name for our bicycle tires and our automobile tires and all the tires that we have that are filled with air. They're all called pneumatic. And they all have a similarity in that they are rubberized and they are somewhat flexible and elastic so that we can force air into them. And, very importantly, they all have a mechanism for allowing air to be put into them and not allowing that air to be released unless we choose to release it. And of course, the mechanism that we're talking about is called a valve. A valve, in all kinds of mechanics, has to do with something that we are able to allow something to pass through a system, and we're also able to shut that thing off. So a faucet in our house or a shower is a type of valve. We allow water to pass through, and when we don't want the water to pass through, we can shut the valve off. So how does a valve work on a pneumatic tire? Well, on a pneumatic tire, we know that our valve is an extension that moves out away from the tire. Always on the inside, of course, so that it doesn't hit the outside of the road. Our tire valve has a screw top to it so that we can screw on a cap so that it does not get interfered with in daily life. And then it has a pin running down the center of this shaft. This pin is attached to a spring, meaning when we push the pin down, the spring will want to push that pin back up. We have to put force on the pin to release it and push it down. At the bottom of the pin is a flap. This flap is the valve itself. A valve is designed in a way that we have an opening, and then we have something behind that opening that when pressurized will keep it shut. So if vacuum pressure is pulling in this way, then it will suck that valve shut and keep the valve from opening. So, like many valves, we need to find a way that we can open the valve. Well, if we're going to put air into a tire, we're going to have to push down the pin at the center of the valve. When that valve is pushed down, the flap here at the bottom is going to be released from the surface of the tire itself, allowing air to move in and enter into the actual tire itself. When there is no longer pressure on that pin, the pin will return to its original place and the flap will seal off the entryway that the air came in. The flap will also have now the air pressure pushing against it, and because the flap is bigger than the opening, that flap is able to prevent any further air from escaping. So of course, this is how a basic valve works in a tire. The next question is, how do we add air to that tire? We don't go and we blow on a tire with our lungs because we don't have enough lung capacity to blow up a tire to the poundage that it is required. So what do? We create machines that can compress air and then release compressed air as we want them to. Today I'm going to show you how an air compressor works, and then I'll demonstrate with one that I have on hand. To first understand an air compressor, we have to say that there are different parts to this machine. The biggest portion of it is what we would call the storage tank. Inside the storage tank, we have an area that we can fill up with pressurized air as much as or as little as we like, and that air will remain there contained until we want to release it through a series of valves. Inside most air storage tanks is some sort of bladder. And a bladder is like a balloon. It is a rubberized thing that can contain air, and that also has the flexibility to move depending on the pressure of the air that's around it. So that bladder will force the air into a higher, more pressurized area until we push enough air in that the bladder is forced down. As the bladder is released, just like the valve that we have for our tire, the air is pushed back out towards the valve that will release it to use. So how do we actually compress the air into the tank? Well, an air compressor has a whole motorized system to it that is designed to force a certain amount of pounds per square inch pressure into this tank. So how does it work? There's an intake in all air compressors, a place where outside air at atmospheric pressure is going to be sucked into the tank and then pressurized to a level that we want it to be. Well, in order to suck air into the tank, an air compressor will always have some sort of little fan mechanism right inside. This vent then has a fan behind it. The fan is pulling air in, and the air is then going to be forced into the actual tank. How does that work? Well, inside our motor here, we have a whole mechanism that is very similar to our internal combustion engine, in that we have cylinders, we have pistons, and we have a crankshaft. Now inside this mechanism is a cylinder with a piston inside. In a normal automobile engine, this would work in a way that a little bit of fuel, gasoline, would be released into the cylinder. A spark plug would ignite that little bit of gaseous fuel, and that explosion created would force the piston down. As the piston moves down, the piston is able to turn the crankshaft. And as the pistons go up and down, depending on how many cylinders or valves you have in your car, it's going to produce that much power. Well, what we're doing now with this machine is kind of the opposite process. We have an electrical motor that is turning our crankshaft. So now the piston, instead of providing the force on the crankshaft is turning the piston itself up and down. The piston has a cylinder and is sealed inside there. The air that is coming in through our propeller or our little fan there is going to be forced into the chamber. Now, there is a valve that sits here on the inside. That's a valve that opens into the chamber, meaning when air is pushing through and coming from the outside, it will force that valve open and create a pathway for the air to enter. What is going to bring the air in here? A vacuum. When the piston moves downward, it creates a vacuum by pulling air in to fill up this empty space that it has just created by moving downward. When that air is pulled in, this valve flap opens up and air from the outside comes in to fill the cylinder. When there's enough pressure in there and the piston has reached its lowest point, the piston is now going to move back up based on the spinning of the crankshaft. As the piston moves back up, this air that has filled the cylinder is now being pressurized. The piston is pushing against the air, forcing the air to live in a smaller space. That pressure is going to cause our first valve to shut. The pressure on it from the inside will push that closed, and no more air is going to come in from the outside, and our pressurized air is not going to go out to the outside. Our pressurized air instead is going to make its way through a second valve, which is going to go down a tube and go into the storage itself. So as the piston and the motor runs, it's constantly doing a cycle of suck in a little bit of air, force that air into the tank, suck in more air, force that air into the tank, suck in more air, force the air into the tank in a very quick, rapid succession, so that eventually this moving piston has drawn outside air and continued to force the air until we get a level of pressure that we're looking for inside our storage. Now, how do we use the air compressor? Once we have stored a bunch of pressurized air inside our tank, we also have an outlet that's going to run out and allow us to use that pressurized air on a tool or on any other type of purpose that we might have for our air pressure. It's going to come out and it's going to run through a regulator. And just as we spoke about with our scuba equipment, regulators are devices that control the amount of air pressure that is released from a storage tank. In the case of the scuba tank, the air is pressurized in the tank, and the regulator only allows out as much air as your body could handle breathing into your lungs. In this case, we're able to control the amount of air pressure that is released. We have gauges that are set up on this tank to tell us how much pressurization is in the tank and how much pressurization can we release. And finally, we have a mechanism where a tube is attached to this device and goes out to our output. Our output is going to be whatever tool or whatever method we're using to take compressed air and use that stored energy in the compressed air to do some sort of a purpose. So let's look at an actual air compressor. So, here we have an actual air compressor itself. My air compressor, just like I showed you in the diagram, is comprised of a storage tank and a motor that runs the compression itself. Now, when we look at my air compressor, we see, like I described before, that we have a motor and we have an air intake valve over here. If we were to look closely inside there, we would see the propeller or the fan that is sucking the air in. And in fact, when I start this motor, I can feel that air being drawn in. And just like we showed with the diagram, the air is being pulled in, put into a cylinder by the piston, and then forced into the storage container down here through this tube. Now, once that air is pressurized, taken into the tank, it is regulated by this device right here. I can control if I want more or less air. I control the amount of pressure that exists within my tank. Sitting up here on the tank are a pair of gauges. This gauge will tell me how much pounds per square inch I have inside the tank, and this will tell me how much I'm going to release on the outlet. So I can have a certain amount of pressure, but by controlling it here, I can release less pressure on that side. Now finally, I have the outlets themselves. These are a couple of valves that keep the tank pressurized and keep everything inside the storage until I connect something to it. When I take a hose and plug it in, there are a series of valves in there that are going to release the air And now the air is moving all the way through my hose and can be transferred to some other purpose. So what might we use this air for? Well, one device is simply an air sprayer. An air sprayer has a very, very simple valve on it. It has a trigger that when I pull the trigger, it opens a valve, meaning that the air can pass through there. When I release the trigger, the valve is closed. When I attach it to the existing pressurized air, I can now push the trigger and release air. And by doing that, of course, I'm taking stored air and releasing it through a compressed area so that it comes out at a higher pressure. Well, what else can we use with an air compressor? Another device is the nail gun. In here, my pressurized air is running through a chamber in the center of the gun. Up here in this big bulky part of the nail gun, we have essentially another high-level compression chamber. And inside there is a pin that can run back and forward, and under very, very high pressure, this pin can run forward and strike the back of one of these nails stored in the nail storage area. It is activated when we put the safety trigger and pull that back. I now can have pressure on the trigger itself. But without that safety going, there's no pressure happening. And so what happens is that when I put pressure on that and I pull the trigger, there is enough air pressure that it is able to send a nail through the system and into the board that we want to actually nail together. The last one I want to share with you today is one that's relevant to our first valve that we're looking at. What I have right here is an air valve. Now this one, as we see, has a little pin in the center of it, and this pin is connected to a valve in the exact same way that our pneumatic tire valve is. In fact, the pins match up. When I add pressure to it, I see that the pin is no longer flexible. The pressure behind the valve is forcing this pin forward. But if I press on the pin, I'm able to release the air through that area in very much the same way that the valve on the tire works. When we match these two things up, we see that I can take a tire with its valve, and by pressing the pin in the center of the tire, in the tire valve, I can release the air out of the tire itself. Anytime we want to remove air from a tire, all we have to do is press that center pin and release the valve. The pressure is now gone and the tire is now pretty flat. But if I want to refill my tire, all I have to do is match up my pressurized valve and get pin to pin with the tire valve. So when I put my pressurizer on that, the pin pushes the pin and both of those valves are released. And the higher pressure contained within the storage tank is now going to be released into the lower pressure contained inside the tire itself. And very quickly, I have a full tire once again. So we see that compressed air has a lot of different uses in the modern world. It can either be used on job sites and building to run tools. It can be used in a mechanic's shop to power their tools, or even in a factory to run things. Compressed air is a way that we're able to store energy and use it later on in many different forms with many different tools.